Hello and welcome to your notes on Python lists. So what's a list? All right. A list is sort of Python's version of an array. All right. What's an array? All right. It's basically a variable that can hold multiple values inside of it. All right. That's a little bit of a simplification, but it works for us right now. All right. So it's a variable that can hold lots of things in it. So instead of just being limited to like, oh, we're storing one number or we're storing two numbers. We can store, several numbers, multiple words, multiple whatever. All right. You didn't realize this, but when you used the function get pixels, all right, that was creating a list of pixel objects. All right. It was creating one sort of list or one sort of entity that had all of the values inside of it. All right. And that's what we're going to talk about today. These variables, these whatevers, that arrays that can hold multiple values. Now, in terms of the syntax, all right, if you're creating a list, right, we start like a normal variable. We've got our name for it. We've got our equal sign. But then we're using these square brackets. And each element is separated by a comma. Now, these elements also have quotes around them because we're dealing with text or string there, but each one is separated with a comma. Down here, where we're creating a list of numbers, we don't use the quotes because they're just regular numbers, but we still separate them with commas. All right. So we've created these lists. How do we start accessing the individual elements of it? All right. So it's going to be very similar to string indexing, where we could access individual letters of the string. We can access individual aspects of our list, all right? And they follow the same numbering sequence, all right? So physics would be index 1, 0, because we always start at 0. Chem would be index 1, CS would be index 2, history would be index 3. All right, same thing down here. This 98 would be index 1, 85 would be 0, 1, 2, 3, 4, and 5. So kind of what we've seen with just about everything we've dealt with, all right, if there are 4 things in your list, they are numbered 0 to 3. Right? There is no element 4 because we're starting at 0. If there are 6 things in our list, they're numbered 0 to 5. All right, so if we were to say print courses of 1, that would just go and print the word chem. We'd be accessing that individual element inside of our list. If we were to say print courses of 3, all right, that would access history from our list. And then if we were to say 1:4, right, that's basically like creating a sublist almost, all right? So this would give us elements 1, 2, and 3, all right? It's going to cut off that last number, just like we've seen time and time again with like our ranges inside of our loops. That last number gets cut off. So we go right up to it, but we don't include it ourselves. So this would create sort of a sublist. All right, so I'm going to designate that with the brackets there, and that's how it would print out. And that sublist would contain chem, CS, and history. All right, so we don't have to just access a single element. We can access sort of multiple elements and get to them that way. Now, a thing that's a little weird in Python that doesn't really exist in most other languages I've dealt with is you can also have negative indexes. So if I were to say print courses of -1, all right, that actually works backwards through the list, and this would print out history. So it would start at the back and then go in the other direction. So this would be -1, this would be -2, -3, and -4. All right. So again, a little different, doesn't exist in most other languages that at least I'm familiar with, but negative indexes do work inside of Python. All right. Now, if I want to change a list value, I can go in and change the actual element. So I can say, all right, courses of 1 now equals AP Calc. And when I print out the list, all right, all the other elements will be unchanged. So it'll still say physics. It'll no longer say chem because that was element 1. Instead, it will say AP Calc. And then the rest of it will stay the same. I'll still have CS, and I'll still have history. All right. And then the same thing here, kind of showing this number 1. So if I were to say nums of 0 equals nums of 0 plus 2, all right, I'm just changing that very first element, and everything else would stay the same. So the 98 would go up to 100, but then the rest of the list would be unaffected because I didn't access those individual elements. All right, so just as kind of a first thought here, it allows us to store multiple values. We can access those values using indexing, and then we can go and change individual values, again, using those same indexes. All right, so some hands-on practice, all right? If you go to the Google Classroom assignment with this, there will be a link to this right here, all right? It's also in the presentation. And basically, the link brings up these 2 lists that have been created. We have a spice list with Ginger, Sporty, Scary, Baby, and Posh, because who's not a Spice Girls fan? And then we have this sat list with a bunch of numbers inside of it. So what I encourage you to do is go through these tasks and try to write the code that's going to carry out each of these. So print out the third item, print out the last item, change the first item in Ginger to all caps, print out the last item, create and print out a sublist consisting of the last 5 numbers. All right, so again, open up REPL, try these out, all right, see if you get the correct results, and then you can come back and we'll talk through each one one by one by one. All right, so pause it and give it a shot. All right, I'm assuming you've given it a shot now, so let's talk through each of these. Again, we've got our 2 lists. They have their index values, so 0, 1, 2, 3, and 4. And then down here, we're looking at 0, 1, 2, 3, 4, 5, 6, 7, and 8. So if we want to print out the third item, Scary, in the spice list, all right, the third item actually has an index of 2. So we would be writing print spice, and then we're using the square brackets and printing out element 2. All right. If we're printing out the last item, right, even though there are 5 items, the last one is in spot 4. So we would be saying print spice of 4, and that would actually be the last item. Right. If we want to change the first item to Ginger, right, all caps, the first item is an index 0. So we would just say, okay, we're accessing index 0, and this kind of treats it almost as like it's its own variable. So we're just saying, hey, that variable spice of 0, change it to Ginger, all caps. Right. Print the last item of the sat list. So again, the last item, even though there are 9 items, is in spot 8. So we would just be saying print sat of 8. And then it says create and print out a sublist consisting of the last 5 numbers. All right, so the last 5 numbers are 8, 7, 6, 5, and 4. All right, so when we print this out, we're going to start at 4, and then you have to remember that you don't actually get the last number, so it's going to be 4:9 if we want the last 5 pieces. Because again, this just gives us 4, 5, 6, 7, and 8, which is what we want, but you do have to kind of recognize and remember that this 9 isn't going to happen, which is what we need here. If you do 4:8, you're only going to get those values, and you're going to be 1 short. All right. So hopefully those went well. And let's see what we got next. All right. So a couple other things that we can do with lists, just so you kind of understand how they work and some of the options we have available to us. So we've got 2 new lists here. One is courses, pretty similar to the one we had before, except AP Calc is back to Chem. And then we have this new list, primes, which is 2, 3, 5, 7, 11, 13, and 17. Yes, 2 is a prime number. It's the only even prime number. And yes, 1 is not a prime number. That's the other one that kids always goof up. But that list is correct. All right, so one thing that we are able to do with lists is we are able to use the length command. All right, and the length command will tell us the number of elements in the list. So if I say print length of courses, all right, that's going to print out the value 4. All right, saying that there are 4 elements. Now, again, I keep harping on this because it's easy to forget, but even though there are 4 elements, they are numbered 0 through 3. Right? We can also add lists together. All right, so what happens when we add lists together? It basically just combines them into one big list. It does not sort them. It does not like alternate back and forth. It would just take the first list and then put the second list on the back of it. So if we were to print this out, we would see 2, 3, 5, 7, 11, 13, 17. That's the first list. And then it would just repeat with the second one and combine it into one single large list. All right, but there's our new list. All right. We can check to see if values are inside of our list, all right, using this in command. All right, this is a special Python command. All right, that's part of the Python syntax. So we can say if the string history is in the list courses, print out this, else print out you are not taking history. So if we were to run this on our code here, we would print out you are taking history. All right, but if we combine the if statement with this in command, we can look for things inside of lists. We can also use a for loop to work through a list. Right? We can say for x in courses, and that will go through the courses list and print out each value on a new line, right? Because each print statement is going to make a new line. So it'll work through the list one by one, and it'll print out physics. And then it's a new print command, so it'll go down a line and print out chem. And then it's a new print command, so it'll go down a line and print out CS. And then it'll go down a line and print out history. All right, so if we have a list, we can use the for loop to iterate through that list, and this X will take on each value in the list. Right, and we kind of saw this with strings where you could say, you know, for X in a string, and then the variable would take on each letter in the string. We've seen this with our get pixels, where the variable takes on each individual pixel. So it's the same idea. If you use this with a list, that loop variable will take on each value in the list and just go through them one by one by one by one. All right. We can compare two lists with like an equality operator. So if we say if nums equal primes, that's suggesting that the two lists contain the same values. And if they don't contain the same values, obviously the else will print out here. So nums is 3, 5, 7, 11, 13. Primes was 2, 3, 5, 7, 11, 13, and 17. So they don't contain the same values. So if we were to run this one, it would actually print out these two lists are not the same. All right, so again, just examples of different ways we can use these lists. All right, one thing I should probably add is it's not just the same values. It's also the same values in the same order. So if they were in different orders in the list, it would not say that they're the same. All right, so here's a second link. All right, so again, this will be in the Google Classroom assignment. It's also in the actual presentation. But if you click on that link, it'll bring you up to a second sort of sample code area where we can where you can practice actually trying to write this code as opposed to just watching the video. So what are the two tasks? One is write the code for counting and then printing out the number of scores in the list that are greater than or equal to 600. Complete the code fragment to make it work, and you should get the answer 31, so that's how you know if it works. And then write the code to sum the total rainfall by adding up all the values in the list rain. Complete the code fragment to make it work. You should get 4.35. All right, so that's what you want to try to actually do on your own. All right, the advice I'll give you is that you're setting up a loop inside of both of these. The first one's going to require an if statement. The second one's not going to require an if statement, but you're setting up a loop that's going to go through each of those lists and perform whatever task needs to be performed. All right, so give this a pause, give it a shot, and then come back. All right, let's see how you did. So on this one, we're counting the ones that are greater than or equal to 600. So if we're counting, we probably need a variable to keep track. So I'm going to make a variable called count. And I'm going to start it off at 0. Right? Then I need to go through my list. So I'm going to say 4, and then I'm going to use x as my loop variable. I could have used anything, but I'm going to use x as my loop variable. And I'm going to go through and look in the sat list. All right, so this is going to go through this list one by one by one by one, and x is going to take on those values as it works through the list. Now, I only want to count it if they're greater than or equal to 600. All right, so that's an if statement. If x is greater than or equal to 600, then I want to count it. So I can just write count equals count plus 1. And that'll keep track of it. Now, I want to know what the final count is, so I should probably have a print statement at the end. So I'm just going to say print, and I'll say the number of scores greater than or equal to 600 is, and then I'll print out my count variable like that. All right. So in that case, it'll keep track inside the loop. When the loop is over, because notice this is not indented, it'll print out the final result. All right. So number 2 says write code that sums all the rainfall. All right, so there's no if here. I'm just summing everything. So again, I'll create a variable called sum. I'll start it off at 0. I will say for x in rain, because that's the list that I'm going to go through. Right? Didn't have to use x, could use whatever I want, but that's what I use as my loop variable. And then inside, I'm just adding them together. So I'm going to say sum equals sum. So the old value of sum plus x is going to get stored in as the new value of sum. All right, and that's it. And once the loop finishes, I can just print out like I did up above and say print the total rainfall is, and then print out my sum variable. All right, so again, just kind of showing you these loops that allow us to walk through the list one by one by one. And then what you're doing inside of the loop is really up to you or the demands of the program. Right? But just, again, kind of showing you how these can be used. All right, 2 more operations. All right, so one operation we saw on the previous slide is that we could get the length of a list by doing length of the list. Other operations that are useful are append and sort. All right, so I've got my list here, grades, which currently only has 1 element. I've got that courses list that we've been using all along. And then I have this new nums list that just has a bunch of random numbers in it. All right, so one thing you can do to a list is append values, all right, which basically means to add values to the end of your list. So if I did grades append A plus, grades append B, when I print out the grades list, all right, B plus is going to come first, all right, because that was the first thing in the list. Then A plus will come next because that was my first append statement. And then B will come third because that was my last append statement. All right, so append is kind of sticking things on to the end there. All right, same thing if it's a bunch of numbers. So when I say nums append 100, all right, that's going to automatically stick it on the end. So we would just print out 12, 8, 9, 5, 3, 8, 10, 7, 6, 2, 0, 1, 11, 4, 6, and then the 100 goes at the end, because again, append is always sticking it on the end. All right. Now, something that's really useful, all right, and also doesn't exist in a lot of the other languages I'm familiar with, is there's just a sort command. All right, we can just automatically have Python sort these lists for us. All right, so if I say courses.sort, all right, that's going to put our list in alphabetical order. All right, so it's going to take this physics, chem, CS history and turn it into chem, CS, history, and physics. All right, so that's super useful that we can very quickly take our lists and get them in potentially the exact order that we want them in, or at least, you know, in alphabetical or a numerical order. Now, when I say it sorts it alphabetically, there's some disclaimers there that we'll get to in a couple slides. But for right now, let's just say it sorts it alphabetically. All right. If you want to create an empty list, all right, new list equals empty bracket, that will create an empty blank, you know, nothing in it at all list. All right, so you don't have to create a list and start with something in it. If you want something to be a list variable, you can just set it equal to sort of the empty brackets at the start. All right, and then I can start adding things to it using the append command that we just talked about. All right, so I could say new list.append nums index 0. All right, well, again, index 0 would be referencing the 12. So this is basically like I'm appending a 12. All right. New list dot append nums, length of nums minus 1. All right. Well, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. But then we added this 100 in this step. So there's really 16 elements in our list. So length of nums minus 1 is basically doing 16 minus 1. All right. And the minus 1 is important because even though there are 16 elements, they are numbered 0 to 15. All right, so by doing the subtracting 1, we're basically getting that last element, which in our case is the 100. So when we print new list, it's just going to print out a 12, comma 100. All right, if we hadn't done this append 100, then it would have printed out 12, comma 6. All right, so again, depending on whether you counted this one or you didn't count this one, you're either getting 12, comma 100 or 12, comma 6. But this length of nums minus 1 will always get you the last element. All right, so that's kind of the easy way to get the last element where you don't even have to know how many things are in there. If you do length of a list minus 1, you're getting sort of the last element there. All right. So let's see if we can use these tools to answer this question. All right, so again, another link, same as before. It's in the Google Classroom or it's linked right on this presentation. But you should see two fairly long lists containing a bunch of exam grades. So it says complete the function min max. It takes a list of numbers as input, and it should print the minimum and maximum values in the list. Hint, use sort to make it easy to find the min and the max. The test code below calls the function twice, once with exam 1 as input and once with exam 2 as input. Your function should work for any list passed in as an input. All right, so again, you're going to create a function this time. And then that function's job is to print out the minimum value and to print out the maximum value. And then you can call the function twice, once with exam 1, once with exam 2, just to make sure that it's working. All right, so again, think about what we just talked about. All right, think about the sort feature. Think about where the first element is. Think about where the last element is, and try to write this function. Come back, and then we'll see how you did. All right, so we're writing a function here. We're going to say def, and they wanted us to call it min and max. And this function takes one list as an input, and I'm going to call that list, I'm going to call that input or that parameter grades. Okay. So if I want to find the min and max values, right, the easiest way to do that would just be to put the list in order. All right, so what I could do is I could start with the command grades dot sort. That will automatically put the list in numerical order. All right. Once the list is in numerical order, I know that the smallest number has to be in the first spot, and I know that the largest number has to be in the last spot. So at this point, I can just say print the word min, and I'll put a colon and a space just for formatting. And then the smallest number is going to be in the first location, and the first location is always index 0. All right, so that would print out the smallest number. And then if I want to do that same sort of thing for the largest number, right, because I've sorted it, I now know that the largest number is in the last location. All right, and I can always find the length of the last location by taking the length of grades and then subtracting 1, again, because those indexes start at 0. So I have to subtract 1 off of it, and that will print out the largest. All right, so it's as easy as just putting the numbers in order, which is one command, and then accessing the first one, accessing the last one. All right. Now, there's a little more that I'm going to talk about, but if you want to practice more of these, if you're like, oh, this is kind of interesting, I want to try to get better with these, codingbat.com has 2 sets of problems, Python list 1 and Python list 2, that give you a lot of opportunities, a lot of interesting problems to kind of test out your understanding of this stuff and see how you do. Now, these next few slides, we're not going to spend a lot of time on them. They're really just to show you kind of some of the different stuff that's possible. All right, so the lists have all sorts of options. Append, sort are kind of the ones that we're focusing on, but there are other list methods that you can use. So append, we already talked about. All right, you have to provide a value, and then it adds that value to the end of the list. All right, there's .clear. That would just wipe out the entire list. So if you wanted to clear out your entire list for some reason, you could do that. Right? .copy returns a copy of the list. So if you're trying to copy the list, right, .copy can return that. .count is you can count the number of elements with a specific value. So if you're like, hey, I wanted to count how many 12s there were, or how many hundreds there were, or how many 65s there were, you could count specific values. All right, so you wouldn't use this if you wanted to count all the values. There we could just use length. But if you're looking for a specific value, you could count the values. Extend adds the elements of a list to the end of a current list. All right, we can also just do this with addition. We saw that when we added the list together, it had that effect. But you can also use the extend command. Index, if you're searching for something and you want to know its index number, I could be like, oh, what's the index number of the first 100 in my list? Or what's the index number of the first, history in my list, or whatever. But you provide some value, and then it returns the index of the first element with that value. If you want to insert something, not necessarily to the end of the list, but at a specific part, you can insert, and you just have to specify the position. So, I want to insert this at index 3, and then everything from 3 on will get pushed back. So there's an insert command. There's a pop command, which removes an element at a specified position. So if you provide an index number, it'll specifically get rid of that one item and pop it off the list. Remove removes the first occurrence of an item with a specified value. Reverse will flip the order of the list. And then sort, we already talked about, will sort the list. Now, you don't have to memorize all of these. You don't need to, have these, drilled into your brain. Sort and append are the good ones for right now. But I just wanted you to be aware that there is a variety of options. There's a variety of things that are available inside of these lists that exist inside of Python. Now, the last thing I want to talk about in a little more detail is sort. All right. And I kind of said earlier, it puts it in alphabetical order, sort of. So let's talk a little bit more about sort, because that is a particularly valuable one. All right, so the default is to sort ascending. All right, so if you just use .sort, it is going to put it in ascending order. All right. If you want to sort it in descending order, you just have to add reverse equals true inside of the parentheses, and that will flip it around. All right, so instead of going A to Z, it will go Z to Y. All right. You can also use custom sorting criteria. All right, why does that matter? All right, why is that something that's valuable to us? Well, if you sort this list in ascending order, most people would say, okay, it goes apple, banana, kiwi, mango, orange. All right. However, if you sort it in Python, all right, it will actually go like this. It will go apple, then it will go banana, then it will go orange, then it will go kiwi, then it will go mango. All right. So what do you think is happening there? All right. Well, it has to do with the fact that when it sorts it, it's actually sorting it using sort of the ASCII codes. All right. And in ASCII, the capital letters come before the lowercase letters. So it's saying, hey, numerically, apple, banana, orange all come before lowercase kiwi and mango. So when we're putting them in order, even though alphabetically we're saying to ourselves, wait a second, shouldn't it be apple, banana, kiwi, mango, orange? They're saying, oh no, the number for apple is the lowest, then the number for banana is the next lowest, then the number for orange is the next lowest, then the number for lowercase k, and then the number for lowercase m. So it's not putting it in alphabetical order as like humans would see it, but it's putting it in alphabetical order by its ASCII code. All right, so being able to use custom sorting criteria is going to let us get around this issue. All right, so we can use Python functions or create our own with these custom sorting criteria. So if I say key equals str.lower, that basically forces it to sort everything as like a lowercase. So that way I don't have to worry about, it goofing up the ASCII values and kind of mixing them up that way. You can also define your own functions. This is getting a little more advanced, and this is not anything that you're accountable for. But if you create a function with only one input and one return value, you can use it as part of a sorting criteria. And sorry, this should be indented. I don't know what happened here, but indented, this is part of the function. So let's pretend you wanted to sort things by like the length of the word, so that the shortest word was first and the longest word came last. All right, you could create a little function that takes in a string as a parameter. It returns the length of the string, and then that function can be your sorting criteria. And you would just say key equals my function, because that was the name that you used. All right, so again, a little more advanced, something you're accountable for, but just sometimes kids are curious. How do you fix the upper lowercase problem? All right, that's how you can fix the upper lowercase problem. Can you define other types of sorts? Yes, you can. You create a function, and that function has to return a single value. Right? There can be other code in here. There could be other stuff that's happening. As long as it only has a single input and a single return value, you can use it as part of a sort. And that whole ascending, descending, and custom sorts can be combined. All right, so you do the ascending, descending part first, and then you follow it with the key part that's either like my function or str.lower or whatever you happen to be doing there. All right, so again, a lot of this stuff that I just showed you is extra. All right, it's not anything that you're going to be accountable for. All right, you don't need to know how to do custom sorts. You don't need to commit all of these list methods to memory. But sometimes kids are curious. Sometimes kids want to know, what's possible, what can they do, what can't they do. Also, if you participate in the programming contest, some of these things may end up being useful. So it's good to be aware of them and know that they exist. But for the most part, you want to be comfortable with, okay, appending things to the end of the list, a very simple sort to put things in order. You want to understand this idea of sort of iterating through the lists. Sorry, this is the sort one. Where's the iterating through the lists? Right here. All right, iterating through the lists and looking at each value in the list, and then you can do whatever you want to do with that value, but kind of setting up loops that go through them. And then this idea of accessing individual elements of the list. All right, so using the bracket syntax there to access individual elements. You can do sublists. You can do, where's the latest one? The length of the list. If you do length of the list -1, that'll always give you the last element. So things like that are kind of what you want to focus on. This stuff is more extracurricular bonus. I'm really interested in lists and I want to know everything I can do. That's what this stuff is for. All right, so I hope this was useful. As usual, if you have any questions, just let me know and we'll go from there. All right, have a great day.